Dear students, after understanding the basics of algorithms, let us go into the first explanation of the first algorithm. See, first algorithm is concerned with the addition and subtraction, right? So we'll see the efficient way of performing the addition and subtraction in the hardware. So first, so here for addition and subtraction we have two algorithms. So let us see the first algorithm. So in the first algorithm, the data is represented in the sign magnitude form, right? So how to represent data in the sign magnitude form? So in sign magnitude form, we have a separate bit for representing the sign. One bit we represent the sign, the remaining bits we use for the magnitude. Like for example, if you use 8-bit data, so one bit we reserve for the sign, the remaining 7 bits we use for the magnitude. You know this? So let us go to the algorithm. Okay. See, first of all, here I want to perform addition and subtraction. I am considering the two numbers as a and b. So here the two numbers are a and b. So these two numbers I have I want to develop, my intention is I want to develop a unique algorithm which can perform both addition and subtraction. That is the intention. So I want to perform both addition and subtraction using the same algorithm. So for that I am considering the two numbers a and b which I want to perform. So if I consider all the cases, so for developing an algorithm we need to consider all the cases. So if I consider all the cases, there are 8 possible cases. So 4 cases for addition and 4 cases for the subtraction. Like these two numbers may be positive, two numbers, one number is positive, another number is negative. So one number is negative, another number is positive, and both numbers are negative. So 4 cases for addition. Similarly, for subtraction also we get 4 cases. So let us go to the algorithm. So for example, in case of addition, what I need to do? So if the signs of two numbers are equal, so when it will happen, so this is the one case, the signs are equal, right? This is the another case, the signs are equal, right? In case of addition. So in case of addition, if the signs are equal, so we need to perform addition. So to know the sign of the result, let us take the reference as sign of A. So if the signs are equal, we need to perform, in case of addition, if the signs are equal, we need to perform addition, and the sign of the result is same as sign of A. For example, you see here, the sign of A is positive, so the result of sign is positive. The sign of A is negative, so the result of sign of A is negative, right? Similarly, in case of subtraction, so let us consider the case of subtraction. So in case of subtraction, if the signs are different, we need to perform addition. For example, you see this case. In this case, the signs are different. So sign of A is positive here, the sign of B is negative here, the sign of A is negative here, sign of B is positive here. So in this case, in both these cases, we need to perform addition, and the sign of the result is same as sign of A. Similarly, right? So what we can say? So in case of addition, so let us now define for addition. So what we need to do for so in 8 cases, two of the cases for, in case of addition, two of the cases we need to perform addition, right? In subtraction, two of the cases we need to perform addition, right? So what are those cases? So this case in case of addition. Similarly, this case in case of subtraction, we need to perform addition, and the sign of the result is same as sign of A, right? So in the remaining two cases of addition, similarly remaining 2 cases of subtraction, we need to perform subtraction. So how to identify that? So in case of addition, if the signs are different, we need to perform the subtraction. Okay. So again, in subtraction, before doing the subtraction, what we need to do? Actually, subtraction means like we need to subtract the larger number minus smaller number. So the intention is we need to perform larger number minus smaller number, right? So first of all, we need to identify the larger number, right? So for that what we need to do, so before performing the subtraction we need to compare the magnitudes, right? So whether a is greater than b, or a is, so in this case a is greater, right? So I need to perform a minus b, right? So a is less than b, or a may be less than b, so in this case I need to perform b minus a, right? So first of all I need to compare the magnitudes, right? So and identify which is the number bigger, right? After identifying I need to subtract the larger number minus smaller number. So when we need to do that, so in case of addition, if the signs are different, similarly in case of subtraction if the signs are equal, so what we need to do subtraction in 4 cases. When we need to do in case of addition if the signs are different, right? In case of subtraction if the signs are equal. In all these 4 cases I need to do subtraction. How to do subtraction? Before doing subtraction I need to identify the larger number, right? By comparing these 2 numbers I need to identify the larger number. Once I identify the larger number, then for example in this case the larger number is a, right? So I perform a minus b, right? So here if you observe the sign of the result, if I want to decide the sign of the result, sign is nothing but the same as sign of a. Since the a is greater, the sign is similar to sign of a, right? Plus sign is negative here, sign is negative here. Similarly in this case if the a is greater, right? So sign of the result is nothing but sign of a. Sign of the result is nothing but sign of a. Or I may get a case, right? I may get a case that b is greater, right? So in this case what I need to do? I need to perform b minus a. Then what is the sign of the result? Sign of the result is nothing but complement of sign of a. Complement means if it is plus sign of, so I am taking, my intention is I want to take the reference as sign of a, reference as a for deciding the sign. So if with reference to a, the sign of the result is complement of sign of a. So here the complement a is positive, so the sign is negative. Here the a is negative, the sign is positive, so sign of the result is positive. Here the sign of the result a is positive, so the sign of the b minus a is negative. Here the sign of the a is negative, so the sign of this b minus a is positive. So like this I need to decide the sign. So similarly if both are equal, what is the result? Result is 0. In case of subtraction if the both are 0, if I do a minus b, if the both are equal I need to get 0. But here you know that in sign magnitude we may get either positive 0 or negative 0. So mostly we need to ensure that the result is positive 0. So right, there is no negative 0, right? So positive 0. So what we do, we need to ensure that the sign is always positive. If the magnitudes are equal, we need to ensure that the sign is always positive, right? So let us once again briefly so what I need to do in this case in order to perform. So what we are developing an algorithm for performing the addition and subtraction, right? For performing the addition and subtraction we are developing an algorithm. So the data is represented in the sign magnitude form, right? So for this, what is algorithm? So we have 2 numbers a and b, right? So if we consolidate all the cases of addition and subtraction, I get the 4 cases for addition and 4 cases for the subtraction. So what I need to do in case of addition, if the signs of 2 numbers, first I need to compare the signs of 2 numbers. So and if the signs of the 2 numbers are equal, I need to perform addition, right? And in case of subtraction, if the signs of 2 numbers are different, I need to perform addition. So how to decide the sign in case of addition? The sign of the result is nothing but sign of a, right? This is regarding the addition, right? Then I need to perform subtraction. When I need to perform, in case of addition, if the signs are not equal, if the signs are different, first I compare the signs. The signs are not equal, I need to go for subtraction. Similarly, in case of subtraction, if the signs are equal, I need to perform subtraction, right? So how to perform subtraction again? So before performing subtraction, what I need to do? I need to identify the larger number, right? Once I identify the larger number, I need to subtract larger number minus smaller number, right? And what is the sign? If the a is larger, the sign of the result is nothing but same as sign of a. If the a is smaller, the sign of the result is nothing but what? Complement of sign of a, right? Now if both numbers are equal, the sign of the result, right, we need to ensure that the sign is always positive. So this is the algorithm. So it's explained here. You go through it, right? Now, for implementing this algorithm, what we require? So for doing addition, we require a plus b. For doing a plus b, we require an adder, right? Parallel adder. So this is one hardware I require. If I do the same if you implement the same algorithm. Similarly, for comparison, I require one comparator. For doing a minus b, one subtractor I require. For doing b minus a, I require one subtractor, right? Two subtractors I require. Similarly, for performing determine the sign, right? I need to check if the signs are equal, signs are not equal. If I want to do compare the signs, I already told in the previous lecture that we require an XOR gate, right, for doing the sign. So please refer it how we compare the signs using the XOR gate, right? So but this is a tedious thing. I need to reduce the hardware. How can I reduce the hardware? What is the idea? So you can avoid this a minus b two parallel subtractor. I can do this a minus b or b minus a. What I told. So instead of this a minus b minus a, what I do? So first in this case, what I told in this algorithm, first I need to compare and identify the larger number. Then I do this a minus b minus a, right? So instead of that, before comparison, so instead of comparing first and doing this, first what I do? I directly perform. If I take the decision that I want to do subtraction, directly I do a minus b, right? How I do a minus b? This a minus b I do with a plus b complement plus 1, right? So if I do this a plus b complement plus 1, if I get an end carry, what is the meaning? A is greater than or equal to b. That's fine. So in this case, what actually we need to do? We need to do a minus b. Very good. I already did a minus b, right? But if I end carry is 0, what is the meaning? So a is less than b, right? So here I want to do b minus a, but I did a minus b. So how to get a minus from a minus b? I did a minus b, but I want to do b minus a. How to get from a minus b? How to get b minus a? Just take 2's complement of this. Okay, just take 2's complement of a minus b to get b minus a. Okay. So this is how we can reduce the hardware, right? Now, right? So that's what I'm telling. So subtraction can be accomplished. So instead of subtraction, I can do this complement and add, right? So for result of the comparison, right? The result of the comparison can be determined after the subtraction, right? From the end carry after the subtraction, right? So like this, I can reduce the hardware. Okay. So let us see what is the hardware I require. So this is the hardware I require. So in this hardware, I want to do, right, a plus or minus b, right? Again, this is what I need to do. Again, a may be plus or minus a, and b may be plus or minus b, and I need to do this plus or minus. Okay. So plus or minus a, plus or minus b. So first of all, the sign of a, if the sign of a, if it is a is positive, I store the sign and in this as and a. The sign of a is positive, I store as 0. The sign of a is negative, I store a as 1. Similarly, if the sign of b is positive, I store sign of a b as 0. The sign of a is negative, I store sign of b as 1. Similarly, the magnitude of a I store in the a register, the magnitude of b I store in the b register, right? Just now I told to perform a plus b, either I want to do a plus b or I want to do a minus b, right? So a minus b I can do with a plus b complement plus 1, right? These two operations I want to do, right or not? So in order to do this operation, right, I told that complementer and parallel adder. What is this complementer? If the mode is, this is a mode bit, if the mode bit is 0, this parallel adder, this, so the output of the complementer will be b. If mode bit is 0, the output of the complementer will be b, right? Now if the, right, what is the input to the parallel adder? One input is a, thus the sum will be a plus b. This is one operation, right? So similarly, if the mode bit of the complementer is 1, I get the, okay, output of the complementer, this will be B complement, right? B complement. Now I also get this input carry as 1, right? Previously mode bit is 0, input carry is 0. Now I am getting input carry as 1, right? Now another input is A. So what I get? A plus B complement plus 1. Okay, let me explain this once more. What I am telling is, so in this algorithm I want to accomplish the two things, right? What is one thing? One thing is I want to do A plus B, right? I want to do A plus B. If I want to do A plus B, what I do? I select this mode bit as 1, right? Mode bit as 0. So what I do? So this complementer will give the output. If mode bit is 0, the complementer will give the output as B, right? B as it is, it will transfer, right? So since the mode bit is 0, the input carry also 0. So another input for this, so one input of the parallel adder is B, the external carry will be 0, another input will be A, right? So the sum will be A plus B, right? This is how perform A plus B operation in this hardware, right? So finally if I do A plus B, the end carry will be stored in this E bit, right? Similarly, if I want to do subtraction in this using the same hardware, if I want to do subtraction, right, using the same hardware, if I want to do subtraction, what I need to do, right? So subtraction can be done with A plus B complement plus 1. So I need to choose this mode bit as 1, so that input carry equal to 1. So if mode bit 1, the output of the complementer will be B bar. Okay, now this will be A, another input, external input will be 1, so the sum will be, we will get A plus B bar plus 1. The result of this will be stored in this, the carry will be stored in this E, external carry, right? So based on this external carry, right, if external carry equal to 1, I can store that A greater than B. If external carry is 0, I can say that A is less than B, right? So this way I can use this hardware. So one more, so you know that AS is sign of A, magnitude of A, this is parallel adder complementer. So this is external carry. Based on this carry I can take this decision. Similarly BS sign and BS magnitude. So finally AVF is nothing but the overflow. What is overflow? So in case of, so generally here, for example, if I want to store, if I want to get a 8-bit result, so 1 bit is reserved for sign, right? The remaining 7 bits I store in this magnitude, right, in this A register. Suppose if the result is greater than 7 bits, I cannot store in this A, right? So if the result is 8 bits, I cannot store in the A. So in that case, the external carry will be stored in the C, so that we indicate as a overflow, right? So if the result of the magnitude is greater than 7 bits, that indicates an overflow that is stored in this. So whenever I get an overflow, I make this a overflow flag as 1. That is the meaning. Now let us go to the algorithm. Okay, so let us go to this algorithm, right? So in this algorithm, right, in this algorithm, what I do? So first of all, in case of addition, okay, so addition, A is called augend, B is called addend, right? In case of subtraction, A is called minend, B is called subtrahend, right? So first in both these cases, what I need to do? First I need to take decision that in case of addition I need to perform addition, or in case or subtraction. In case of subtraction, 2 cases I need to perform subtraction, or in remaining 2 cases I need to perform addition. So in case of addition, what to do? First I compare the signs, right? If the signs are equal means this XOR gate value will be 0, then I need to do addition, right? Similarly in case of addition, if the signs are not equal, then I need to do the subtraction. Similarly in case of subtraction, if the signs are not equal, I need to do addition. If the signs are equal, I need to do subtraction. So based on this XOR gate, I told, right, how to compare signs, and know that using XOR gate we compare the signs and take decision that whether the signs are equal and signs are not equal, right? Once I do this, what I do? So I take, now in this both cases I took decision that I want to perform addition. Then I need to go with this flow, right? What is this flow? So how to perform addition? Just to do this micro operation. One data magnitude is in A, another magnitude is in B. Perform A plus B, and the result is stored in E, right? So if so whatever the E, so if E equal to 0, there is no overflow, right? So as I told in the third unit first part, that if in case of addition only we get a overflow, in case of subtraction we don't get a overflow. So if e equal to 0, no overflow, but e equal to 1, there is an overflow. So you just indicate this e equal to 0 or 1, whatever maybe we get, that value just a push to the AVF. So if AVF equal to 0, so if e equal to 0, AVF will be 0, no overflow. If e equal to 1, AVF equal to 1, there will be overflow. So just push this e value to the AVF. This is about the addition, right? That's as simple as it, right? So but in case of subtraction, what I told, in case of subtraction we need to do, directly I do a minus b. How to do a minus b? A plus b bar plus 1, right? So this micro operation I do, right? So once I do this micro operation, if I get e equal to 1, what is the meaning? A is greater than or equal to b. Very good. So if a is greater than, I need to do a minus b, I did that, right? So if e equal to 1, a is greater than or equal to b, right? Now what? Again, a is greater than or equal to b, a may be greater than b or a may be equal to b. Two cases are there, right? So if a is a, if I check for the a, right? If a is equal to b means what I get the result. So here the result will be 0, right? If a equal to b, the result will be 0, right? If a equal to b, the result will be 0. So what I told, if the result will be 0, I need to ensure that I get a positive sign. For that I need to push as to 0 to ensure that I get a positive result. That's what I told, right? While develop, so I need to ensure the result is positive. So to ensure that result is positive, I need to make a as 0, right? So if the a is greater than b, already I did the operation, right? So the result is there in the a. So here I did this already. The result is there in the a. So end the algorithm, right? Now, but if I won't get an end carry, what is the meaning? A is less than b, right? In this case, what I need to do? I need to do b minus a. But what I did a minus b. So I did a minus b. The result is a minus b result. I put in the a, right? How to get back b minus a? Just take the 2's complement of this a value to get, right? How to get 2's complement of it? Just take 1's complement, right? Just take 1's complement and add 1, right? This is what I do. So first take 1's complement. So what I see, just what I am doing here, I did. So in this case I need to do b minus a, but I did a minus b. So I am getting back from b minus a, I am getting back a minus b. For that, what I need to do? Just take the 2's complement of the result. Okay, a complement plus 1, right? So first I do a complement, 1's complement I'll get, then I add plus 1 to get the 2's complement. Also what I told, the sign of the result is nothing but complement of sign of a. For getting the complement of sign of a is complement as, and end the result, right? So this is the algorithm. So you please go through it. Thank you.